So here's the first example that we want to look at. X squared minus 5x plus 6. Now, in terms of factoring, this is what we tend to refer to as a simple trinomial. It's called a simple trinomial because this coefficient that's in front of the x squared term is 1. So because of the fact that that coefficient is 1, we call it a simple trinomial. Now, to factor simple trinomials, we have kind of a shortcut. And that shortcut is we want to take a look at this third term, so 6, and we want to find two numbers that will multiply to equal 6. And those same two numbers should add to equal the middle term, -5. Now, for this example, these numbers are relatively small, but for some factoring questions, you might have very large numbers to deal with. And so if you get stuck, what you want to do is start by listing out all of the sets of numbers that will multiply to equal 6. So for example, we've got 1 times 6, -1 times -6, 2 times 3, -2 times -3. Okay? And the bigger this number is, likely the more factors you're going to have to list out. So then we look at that list and we check to see which set of numbers adds up to equal -5. So if we go down this list, -2 plus -3 will equal -5. And so we know that those are the numbers that will work for both statements. When we find our numbers, we're going to go back to the factoring question and write this trinomial in factored form as x minus 2, because that was the first number that we found, times x minus 3, because that was the second number that we found. If we were to do a quick expansion of this, we would get x times x, x squared, x times -3, -3x, -2x here, so -3x plus -2x gives the -5x term, and then -2 times -3 would give +6. So we know that x minus 2 times x minus 3 is the correct factored form. Okay, here's another expression that we can factor. X cubed minus x squared minus 4x plus 4. Now in grade 10, most of the expressions that you saw that you had to factor, most of them were quadratic expressions, meaning that the highest power of x was 2. And so for 4 terms, we want to look at a method called grouping in order to factor this. Okay? Now what grouping means is we're going to literally group the first 2 terms together and the last 2 terms together and common factor out of each of those groups. Okay? So if we look at just the first 2 terms, the factor that's in common between those 2 terms is x squared. And in brackets, we write what's left over when we divide x squared out of those 2 terms. So we're left with x minus 1. Because if we expanded that again, we would have x cubed minus x squared. Then we look at the second group. And in common with those 2 terms is -4. Now, I only took out a negative because there was a negative in front of this term. And so this way, I'm not starting my bracket with a negative. When I take out a -4 as a common factor, I'm left with x minus 1. Well, look, I now have these 2 factors in common. X minus 1 shows up in each of these terms. And so what we can do now is take out that common factor of x minus 1. We've got the first term here and then the second term here. They both have a common factor of x minus 1. I can take that out in front as a common factor and then write what's left over from those 2 terms. So in the first term, if I divide that term by x minus 1, I'm left with x squared. And in the second term, if I divide this term by x minus 1, I'm left with -4. Now actually, we're not done factoring this yet, because if we look closely at this bracket right here, This is actually a difference of squares, and so we need to factor it further. If you remember from grade 10, in order to factor a difference of squares, you might want to take a second first to rewrite it as something squared minus something squared. So in this case, x squared minus 2 squared. And once you've rewritten it like that, it's much simpler to put it in factored form in the brackets. So what we get is x minus 2 times x plus 2. Okay? And the reason is because if we expand this again, we get x squared plus 2x and then minus 2x. So there's no x term in the expanded form. And then negative 2 times 2 is negative 4. So if we expand this again, we get x squared minus 4. This is our final factored form. Okay, here's another one. Let's factor 2x squared minus 7x minus 15. Okay. I'm actually going to show you two different ways of factoring the same trinomial. Okay. Depending on the method that you used in grade 10, you may have been taught a method called trial and error, or you may have been taught a method called decomposition. Your teacher may have also taught you other methods of factoring trinomials, but usually any of those other methods would fall under one of these two categories. It would probably be very similar to one of these two. Okay. Now this is what we call a complex trinomial. And the reason we call it complex is because the coefficient of x squared is something other than 1. Okay, and that's what makes it complex. We can't use that shortcut that we used before. So to use decomposition, we want to start by finding two numbers that will multiply to 2 times negative 15. So we want two numbers that will multiply to equal negative 30, 2 times negative 15. Those same two numbers have to add up to equal negative 7, this middle term. So this method is kind of similar to the shortcut you used for simple trinomials, but instead of just multiplying to equal the third term, we want to multiply to equal the coefficient of the first term times the third term. So again, if you're stuck, you want to write out a list of all the numbers, pairs of numbers that will multiply to equal negative 30, and then try and find a pair that will also add to equal negative 7. So when you find those numbers, you should find that negative 10 times positive 3 will work for both statements. Okay. Now, with these numbers, negative 10 and positive 3, in the method of decomposition, what we want to do is use those numbers to replace this middle term. So instead of negative 7x, I'm going to write negative 10x plus 3x. Okay? So this is the decomposition part. I'm decomposing or breaking up the middle term, negative 7x, into two pieces. Because negative 10x plus 3x is still equal to negative 7x. I've just broken it up. Okay? Now what we do is we continue by factoring by grouping. So I'm going to group this into the first two terms and the last two terms and common factor out of each group. So in the first group, I've got a common factor of 2x, and I'm left with x minus 5. And in the second group, I've got a common factor of 3, and I'm left with x minus 5, which is a good thing because now I have a common factor of x minus 5 that I can take out. And then my factored form is x minus 5. In the second bracket, I'm left with 2x from the first term and 3 from the second term. Okay? You can do a quick check to make sure that if you expand this, you should get this original trinomial back again. All right, let's try this same one using a trial and error method. Okay? Now, using trial and error, we're going to go right away to the factored form. So we're going to set up two sets of brackets. Okay? And we know that the first term in the first bracket and the first term in the second bracket have to multiply to equal the first term in the trinomial. So I want to write in two factors here that will multiply to 2x squared. Well, I could pick 2x and x. That will multiply to 2x squared. Okay? Now, the bigger this number is here in the first term of the trinomial, the more possibilities you might have here for factors. And it's called trial and error for a reason. You want to keep trying different pairs until you find one that will work to expand to this whole trinomial. Okay? Now, in the second position in each bracket, we want factors that will multiply to equal negative 15. Okay? Now, there's some different sets of numbers that will multiply to equal negative 15. We could use negative 1 times 15. We could use negative 15 times 1. We could use 3 times negative 5 or 5 times negative 3. Okay. So we want to try one of these sets of numbers. Let's say we try positive 5 and negative 3. What we want to do is make sure that when we expand this, we get the original trinomial back. Well, if I expand this, I'm going to get the middle term from the 5x, and then here, negative 6x. So 5x plus negative 6x, that's equal to negative 1x, not negative 7x like we wanted. And so we know that the positive 5 and the negative 3 don't work. Okay? True to its name, it is called trial and error. So we just want to try another combination. Okay, so that one did not work. Let's try, again, I'm going to stick with 2x at the beginning of the first bracket and x at the beginning of the second bracket. Let's try another combination. So instead of positive 5 and negative 3, let's try negative 5 and positive 3. Okay. So if we expand that, the middle term we would get negative 5x plus 6x. And that would equal positive 1x. Well, that's still not what we want. We want negative 7x. So again, that one doesn't work. Trial and error. We keep trying. Again, 2x at the beginning of the first bracket, x at the beginning of the second. This time let's try it in a different order. So instead of the 5 in the first bracket, let's do the 5 as part of the second bracket. So let's try negative 5 here and a positive 3 over here. Okay, now if we were to expand this, we get positive 3x and then negative 10x, which does in fact equal negative 7x. And so we know that this is the correct factored form of the original trinomial. Both of these two methods have their advantages and disadvantages. What you want to do is try and figure out which method works for you. Okay, next one, let's look at 6x squared minus 19x plus 15. Again, this is a complex trinomial, so you want to look at either using decomposition or trial and error as a method to factor this. Okay, so again, I'll show you both methods. So for decomposition, we want to find two numbers that will multiply to equal 6 times 15. 6 times 15 is 90. Those same two numbers we want to add to negative 19. Okay? So you might want to start by listing out factors of 90 and then look through that list to find a set that will add to negative 19. The numbers you find should be negative 10 and negative 9. And so then to get factored form, we're going to decompose or break up the middle term. So we're going to write it as 6x minus 10x minus 9x from the two numbers that we just found here, plus 15. and then factor by grouping. So group the first two terms and the last two terms and find common factors in each group. So in the first group, the common factor would be 2x, and we're left with 3x minus 5. And in the second group, the common factor, again, would be 3, and we're left with 3x minus 5. Common factor now of 3x minus 5, and so I can common factor that out. And the factored form is 3x minus 5 times 2x minus 3. Okay, using trial and error, we know that for the first term, we want two factors that will multiply to give 6x. So let's start with 2x and 3x. It could also be 6x and 1x. We just don't know. We have to try, figure out our mistakes, and then try again, hence trial and error. Okay, then we want to come up with the last two terms in the brackets, and we want to come up with those so that they will multiply to positive 15. So we might want to try 5 and 3. Okay. If we use 5 and 3, if we multiply out for the middle term, 5 times 3x is 15x, and 2x plus 3 is 6x, and so we get 21x. Okay, well, that's not what we want. We want negative 19x. So let's try this again. Not that one. Let's keep using 2x and 3x. If we find that this doesn't end up working, then we can always switch to 6x and 1x. Okay. And this time, let's try using negative values. So let's do negative 5 and negative 3. Okay. If we expand this, we're going to get negative 15x and then negative 6x. Well, now we get negative 21x. So that doesn't work. Let's try this time switching the negative 5 and the negative 3 and see if that works. So 2x here and 3x here. And now we're going to use negative 3 and negative 5 and see if that works. So now we expand, we get negative 9x and negative 10x, which does equal negative 19x. So this is the factored form that we want. Okay, next one, 4x squared plus 20x plus 25. Whenever you see a trinomial where right away you recognize that the first term is something squared and the last term is something squared, that might be a hint to you that it could possibly be a perfect square trinomial. And perfect square trinomials have shortcuts to use for factoring. And so if you can recognize it as a perfect square trinomial, then you don't have to go through all of the process of decomposition or trial and error. So to recognize it as a perfect square trinomial, we can see that the first term is something squared, and we can see that the last term is something squared. But a perfect square trinomial has to be either in the form a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. Okay. Now, this one we'd be comparing to the first form because the trinomial we're looking at has a positive middle term. Okay, so we want to see if it follows this pattern. So here, let's first of all rewrite this as 2x all squared. And the last term we can rewrite as 5 squared. Okay. So now we know that a is 2x and b is 5. Okay. So we want to see if this middle term will work. So is the middle term equal to 2 times a, which is 2x, times b, which is 5. So here we get 2 times 2 is 4, times 5 is 20, times x is 20x. So this does work as a perfect square trinomial. So once we see that it is a perfect square trinomial, then we can factor it as a perfect square trinomial. And a perfect square trinomial will factor to a binomial squared. Now, in the case of this form of a perfect square trinomial, where the middle term is positive, it's going to factor to a plus b all squared. Okay? And so we take our value of a, which we know is 2x, and our value of b, which we know is 5, and we know the middle sign is going to be positive because the middle term of the trinomial is positive. So 2x plus 5 all squared. Okay, let's take a quick look at another perfect square trinomial. 25x minus 70x plus 49. Now we do want to do a check to see if this is a perfect square trinomial. And so our check would be looking at the first term, see if it's something squared, and we're going to rewrite it as something squared, so 5x squared. The last term here can be rewritten as 7 squared. And then the middle term, we want to write as 2ab. So 2 times 5x, which is the value of a, times b, which is 7. 2 times 5 is 10, times 7 is 70, and we've got the x in there. So this is indeed a perfect square trinomial because it can be written in that form. Now, if that middle term is negative, then we're looking at the form a squared minus 2ab plus b squared, and that form is factored as a minus b all squared. Okay, and so we find our a value, which is 5x, the b value, which is 7, and the middle sign is going to come from the middle term, so minus and all squared. So that's the factored form of that trinomial. All right, let's do one more. 8x squared minus 98. Now, whenever you see just two terms, so it's not a trinomial, it doesn't have 4 terms, we're not looking at factoring by grouping. Whenever you see 2 terms, you want to ask yourself if it's possibly a difference of squares. And for a difference of squares, we want to see something squared minus something squared. Well, 98 isn't something squared, and 8x squared isn't something squared, but we can common factor this first. So let's look for common factors between the 2 terms. There is a common factor of 2, and then we're left with 4x squared minus 49. Well, what we have left here in the brackets is definitely a difference of squares. We can write that as something squared, so 2x squared minus something squared, in this case 7 squared. Okay? Now a difference of squares is always going to be in the form something squared minus something squared. Okay? And for factored form, you're going to take the square root of the first term, so a, plus the square root of the second term, so b, and then times a minus b. Okay? Doesn't matter, the order of the brackets doesn't matter, so you could have the minus in the first bracket and the add in the second bracket. That part doesn't matter. So here, we're going to keep that common factor of 2 out in front. We can't get rid of that. And then in factored form, the a is 2x. So that's going to go at the beginning of each of the 2 sets of brackets. And the b is 7. So that goes at the end of each of the 2 sets of brackets. One of the brackets has a plus sign, one has a minus sign. So that is our fully factored form.